The bed fit on my CJ0618 Chinese mini lathe is really bad. The headstock, tailstock and the carriage all don't fit correctly, as if the prism on the ways is too large or the groove in the parts isn't deep enough. This reduces the rigidity of the machine a lot and ruins the precision for many operations. In a previous video, I tried to measure how bad this problem is while trying out a set of gauge blocks. I got a rough sense of the scale of the problem, and I've spent a while working out how I can fix it. In this video, I'm going to try and improve the fit using shimming and scraping to try and get a really good contact between all three parts and the bed. I'm learning from scratch as I go, so a lot of my techniques will be unpracticed or downright wrong. Advice and suggestions are welcome, but please don't take any of this video as an example to follow. There are far better YouTubers to learn about machine rebuilding from, and I'll include some pointers later in the process. Welcome to Adventures with a Very Small Lathe. The first part I'm going to work on is the tailstock. It's in really bad shape and probably isn't worth saving, so I can afford to be really experimental with it before I give up. Let's quickly go over what's wrong with the fit of this part. The problem with the fit is the depth of the prism groove doesn't match the prism. The base has to tilt for the back to be in contact, at which point it's only supported at a single point at the back. At the same time, the two faces of the prism are only in contact at these 2 points instead of across the face of the contact area. Downward pressure will force the groove onto the prism, which will force the back of the tailstock away from the bed. Clamping the front of the tailstock base to the bed prism highlights this effect. With the groove forced into alignment on the prism, the back edge is lifted up well away from the bed. This means that the tailstock is unstable and not rigid, especially when it has downforce on it, such as the tailstock locking lever. In the previous video, I already measured what it would take to make the top of the base parallel to the planar part of the bed. With it clamped to the prism, I can confirm that the distance is about the same as that measurement, using the gauge blocks in a similar way. I'm going to assume that the top of the tailstock should be mostly parallel with the bed plane, as the prism groove has been machined relative to that reference. There are 2 obvious ways to achieve that. The first is to remachine the prism groove to make it quite a bit deeper, which will allow the whole part to sit lower so the underside can rest on the bed with the surfaces parallel. The second is to add fairly large fixed shims to the back, allowing it to rest securely on the bed with the surfaces parallel without needing to change the groove. The tailstock doesn't have enough material to machine the groove much deeper and still be strong, so I'm going to try shimming. If I look at the underside of the tailstock, I can see there are 2 pads which should rest on the bed. To make the right shims, I need to measure the size of the contact area of these pads. The only material I had to hand of about the right thickness was this mild steel plate. I know this isn't the perfect material for hand scraping, but I thought it was worth a try to learn how well it works. I marked out a single piece big enough to make the 2 shims and cut it out by hand with the hacksaw. I'd forgotten how much I hate hacksawing by hand, and I've been working on a project to sort out a usable vertical bandsaw without breaking the bank. More on that in a later video. I then marked out and cut the piece in 2 to make 2 shims. I used a hand file to straighten the rough sawn edges a bit and remove burrs from the edges and corners. I'm going to glue the shims in place, so I use a file to scuff up one face to get a really good key for the adhesive. I also use the same file to scuff the locations on the tailstock base where the shims will go, then clean off all the contact faces with acetone. I'm going to use JB Weld to fix them, as it's a really easy to use metal epoxy that's very straightforward to get hold of. It's mixed equal parts of resin and hardener, and the two different colours make it really easy to tell how well the mix is going. Once the mixture becomes a uniform grey without streaks, it's clearly fairly well mixed. I put epoxy on both sides of the joint as it makes it easier to be confident both faces make full contact, but it probably means there's more epoxy in the joint than I really need. I need to make sure I get a fairly consistent film of epoxy without large lumps to make sure the shim will sit flat. To this end, I tried my best to smooth the epoxy out and make sure it was in a film without too much excess. I tried to place the shims fairly exactly, though it occurred to me later I could have made them oversize and then trimmed the edges after fixing them in place by filing or machining. There's a lot of excess spilling out when I press the two parts together. As I increase the pressure, the joints get stiffer and less inclined to slide about. The stiffness may be due to the iron powder in the epoxy gripping on the two parts. I use small clamps to hold the shims in place while the epoxy cures. Once the joints are clamped and secure, I use some card to clean away the excess glue. I leave it a full 24 hours and more to cure, as I want to make sure it's strong enough to be machined. Once the cure time has passed, I remove the clamps, and the shims seem to be fairly firmly in place. Let's see how it looks on the bed. It looks way more level, so that's a good start. The part already fits to the bed much better than it did, especially at the prism side, but there's a significant gap between the edge of the shim and the flat bed. It looks like the shim isn't as parallel to the casting as I'd hoped. Poking around with the feeler gauge shows me the shim is only making contact at its inner edge, with a significant gap at the outer edge. Before I investigate any further, I'm going to check for wobble with the dial indicator. There's a bit of movement there, which is not at all surprising at this stage, but it's very little considering the two shims have just been rough glued in place. As part of getting the fit right, I'll have to completely get rid of this wobble and ensure the base is completely stable on the bed. To try and visualise where the contact is being made, I'm going to try and use some spotting blue. For the blue to work, the ways will need to be clean, so I need to clean off the whey oil first. I start by putting the spotting blue directly onto the ways and try to spread it out with an ink roller. I'm really showing my lack of experience here, as I'm using way too much blue and putting it straight onto the bed doesn't work well, but the whole point of this phase of the project is to be a learning experience, and this is one lesson I've learned through experience that I'm unlikely to forget. The raw spotting blue is way too thick to spread out like this. Even when I've thinned it out a bit and got it to spread out, the film is way too thick. With this much blue, both sides will be completely covered and there's no useful insight into the contact. After adding some WD-40 to thin it out, spreading it around, covering the tailstock base with thick layers of blue, mopping 90% of it up and then spreading out the remainder into a thin film, I eventually got a print which appeared to show me something useful. I can clearly see where the shims are only making contact near the inner edge. The smeared lines across the shim are probably because of my film of spotting blue is still too thick. On the prism side, there are signs that there's face contact between the prism and the matching groove. This is a great start, but I need to get a much better print to provide more detail and confirm whether it's actually better. Let's see why the shims aren't making good contact. Resting this parallel across the shims, it's easy to see that they're both at an angle. Straight away I can guess that this is probably because the type of clamps I use don't provide even flat pressure and tend to squeeze harder on the side closest to the clamp bar. This bias combined with the soft clamp jaws to force the shims onto an angle as they cured. Lesson learned, and nothing we can't fix with a bit of machining. I set up the part with two seating surfaces of the base resting on the vice jaws. This should make sure I'm machining the shims parallel to the right reference. The idea is to machine both shims to the same plane, and that plane should be close to parallel to the prism groove. I'm using a 2-flute solid carbide end mill, which usually cuts a bit better than 4-flute on this very small, flimsy milling machine. It needs all the RPMs I have due to the high cutting speeds of coated carbide. There's some rattle because the end mill hasn't been properly tightened into the collet and has started to work its way loose, but that's not the fundamental problem. Unfortunately on this axis the machine doesn't have enough travel to machine both shims, so I'll have to flip the whole work setup 90 degrees. I don't care about the part's alignment on the XY plane, so there's no need to tram the vice jaw in. The machine still sounds a bit rough, but this is because it's cutting through the hard black mill scale. Once I get through the mill scale, it sounds a lot smoother and the finish improves a lot. I just need to make sure the surface of both shims are on roughly the same plane, so I mill around each pad at the same depth until they're both clear. Hopefully that's a good start, so let's go back to the bed and see how the fit has improved. The dial indicator now shows that most of the movement has gone, but it's not rock solid yet, so what are the next steps? I'm planning to try hand scraping, which is a technique involving removing tiny amounts of metal with a hand tool until the surfaces fit together as well as possible. I've never tried it before, so I'm starting from scratch based on reading a couple of old books and watching a load of videos. First I need a tool, and the first I was able to get my hands on was this steel bladed scraper from eBay. The blade is blunt and needs to be ground to a curved shaped cutting edge with the right rake angle. The radius depends on a number of factors, so as I'm working on a small machine, I'm starting with a 60mm radius to see how I go. The edge needs to be ground to a 5° negative rake. Unfortunately, this cheap bench grinder doesn't have adjustable tool rests or a scale to judge the rake angle. I'm doing my best to get the rake by pitching the edge of the scraper up, but I think I got the rake too high. As I inspected the result and adjusted the way I was holding the tool, I got closer to the 5° I was going for. I think the rake is to ensure that the scraper doesn't dig into the material and reliably removes a small chip of metal. Now the basic geometry is correct, I need to hone it on a bench stone, which I'll do off camera. Scraping involves pushing the sharp edge across the surface to scrape away a thin slice of metal from the desired spot. The part needs to be held pretty firmly, so I bolted my larger machine vise down to the bench. To start with, I'm going over every part of the contact surface to establish a basic scraped pattern. Straight away I've screwed up by using the wrong edge of the scraper, the opposite side with the positive rake angle. There's a reason why I ground this side of the tool this way rather than symmetrically grinding a negative rake on both edges, but that reason won't be obvious until later. The process seems to be working as I can see material being removed and I can see marks on the metal surface, but the blade doesn't last long before I need to resharpen. It doesn't look great though, and it doesn't look like the examples of a scraped surface I've seen in books and videos. For the time being I don't know why, so I'll keep experimenting. I don't even really know if this tool is intended for this type of work, but it was all I could find through my usual tool sources for reasonable money. To scrape the other shim, I turned the part 90 degrees in the vise. I can't quite reach the near edge of the shim working in this direction, so I flip the part around to finish this pass. To scrape the groove sides, I need to rotate the base by 45 degrees until the surface to be scraped is level. The blunt end of the scraper is too large to get into the corner, and this is why I intentionally ground the other edge with a positive rake angle to scrape these surfaces. This surface feels a lot nicer to work on, and the end result looks a little bit better. The obvious difference is this is part of the original cast iron lathe part, whereas the shims are mild steel. By the time I finished this first pass, I was pretty fed up. The whole process so far has felt quite difficult. It's difficult to get the scraper edge to cut, and the tool's steel edge needs to be constantly taken back to the bench stone to be re-honed to keep it cutting. I had to re-hone many times off camera just to complete a single pass of a very small area. It's pretty clear my technique at this stage is terrible, but I'm doing a lot wrong, but I have an idea there may be one thing I can do which will help a lot. There's got to be a reason every video I've watched uses a carbide scraper, so for the next step I'm going to put a lot more effort into getting a better scraper with carbide blades. After the pass is complete on every surface, I remove burrs raised by the scraping using a small bench stone, and remove the swarf with a brush. I then use a cotton rag to remove any remaining fine debris before checking the contact and fit. Most experienced scrapers seem to prepare their spotting blue on a smooth, flat surface like a surface plate. I don't have a surface plate yet, so I'll try this piece of glass. The paper underneath is to make it easier to see what's going on. I start with less spotting blue this time and add some WD-40 straight away. I mix the two together with a stick and they mix pretty easily. I'm using Stewart's Micrometer Engineer's Blue, which is grease-based. Once it's been thinned down and mixed well, I spread it out with an ink roller. It looks like I still have more than needed, so I shove the bulk of it down to one end with the roller. With a small amount of the blue mix on the roller, I roll it onto the ways of the lathe. It seems to apply into a good thin film pretty easily. I place the tailstock base onto the blued area, move it a little along the ways to make sure contact is made, then flip it upside down to take a look. I can now see clear, unsmeared contact marks where the surfaces were in contact. On the shims, the contact areas are very small, but rather than being only at the inner edges, they are now along the back edge. In the groove, it looks like my spotting blue film was too thin, as I can barely see the markings on the back. On the front, I can see faint marks, and they are already distributed along much of the length. There's an obvious stronger contact point on the right, where it looks like there's a ding in the metal. At this point, I can't face doing any more scraping with the steel scraper, but fortunately my searching has paid off, and I found a hand scraper with carbide blades. It was more expensive than I was originally planning to spend, but I'm getting a much better feel for this project and getting more committed to a good outcome. This one is made by Sandvik, and I suspect it's a bit heavy duty for what I'm doing, but I'm hoping it'll work. The carbide blades from Sandvik are really expensive, so until I know what I'm doing, I'm going to experiment with a cheaper source of carbide. These are carbide paint scraper blades, which come in cheap packs of 10, which I can afford to experiment with and mess up plenty without breaking the bank. Carbide needs a very hard wheel to grind it, so I'm using a cheap imported resin-bonded diamond wheel. I made an adapter to make it run well on this bench grinder. If there's any interest, I can upload a video from the footage I recorded of making the adapter and setting it up. Before I do anything else, I'll take off the blade's edges so I don't risk an accident while I'm grinding. I then need to reduce the blade to a suitable length by cutting off the ends either side of the mounting holes. It's not super easy to cut a clean line with the edge of this diamond wheel, but I can at least score a straight line across where I want the blade to break using the edge of the wheel. The dust that comes from carbide is very hazardous if breathed in, so extraction is important. I've solved this by setting up a vacuum cleaner with a nozzle shape to sit under the rest and catch as much dust as possible. Snapping the end off from the vise leaves a really jagged edge, but this is easy to clean up again on the dining wheel. Unlike grinding steel, I'm not worried about the grinding heat affecting the material. However, I do need to make sure it doesn't burn my fingers, so I dip it regularly in water as it starts to feel hot. Just like the steel scraper, I need a radius on the cutting edge, and I'm aiming for the same rough 60mm radius as before. The fixed tool rest fortunately seems to be in the right position to give me roughly the 5-degree rake I need when grinding thin stock on this wheel, which saves me from having to find a way to hold the blade at a specific angle. Carbide scraper blades are often ground with a negative rake on both edges, leaving a line down the middle of the blade, but I'm still experimenting, so I'm not going to spend time grinding both edges of this blade until I know whether it works. I hone the edge on a fine diamond sharpening plate, being careful not to allow the blade to dig through the diamond grains into the back plate. It's fairly tricky to hold the blade at the right angle while covering the full radius of the cutting edge, but I think I'm getting it done. From reading around the subject, this honing step can be done a lot better with a low-speed grinding machine and a tool rest set to the correct angle, but this will have to do for now. The edge isn't quite the mirror finish I've seen on other videos, but I think it's good enough to try out. The improvised blade seems to fit into the scraper clamp, no problem. Let's see how it scrapes. That's immediately way better, even on the steel shims. I'm trying to remove only the blue part which made contact with the bed. The idea is that after multiple passes of removing the high points that make contact, the surface gets closer and closer to matching the other surface which it should be making contact with. My technique is really messy, and I suspect I'm not pressing hard enough to scrape much material. For some reason I thought this was still in shot, but to fill you in I flipped the base around to scrape the other side of the prism groove. Once again I deburr the scraped surfaces with a stone, brush away the swarf and wipe the surfaces down with a rag. The blue mix on the glass has stayed workable, so I just apply it straight away using the roller. This print looks as though the film was too thick, so I'll redo it, but it's giving me a reasonable idea of where the contact points are. After a new, better print, I did another scraping pass. I'm getting used to the feel of the scraper, but I still haven't found the knack of flexing the handle to apply pressure that I've seen in videos. I'm deliberately scraping further into the groove than the blue marks go because this is beyond the top of the prism, so can never make contact, and I don't want to accidentally create a notch at the prism's edge. The two sides of the prism groove are making face contact, but not symmetrically. This suggests that I'm close to the right fit, but not there yet. Time for another print. This is a clearer print, but it seems to show that I'm not getting a pattern of many fine contact points I should. I also don't seem to have made much progress, which reinforces my sense that I'm not removing enough material. The contact area on the front side of the prism looks like a good spread of points, but there are few of them. The back side of the prism looks more like a smear, even though I think I'm getting a decently thin film. My working theory is still that I'm not scraping hard or deep enough, but I'm still working out the technique, and it's not easy on these small contact areas. So far I haven't needed to resharpen the carbide blade at all, but I thought I'd stop and hone it at this point to make sure it doesn't get blunt. The carbide blade is not only consistently way easier to use than the steel scraper, but it also keeps its edge for way longer. Honing it while still fitted to the scraper turned out to be way easier than holding the blade in my fingers, so I'll do it this way in future. After another print, the contact is looking better, but still some way to go. On the shims, the area is starting to be more than just the far edge, though less than half of the shim is in contact yet. The mild steel of the shims is gummy and unsatisfying to scrape. The cast iron of the main casting has a way better feel, but during this pass I think I'm pressing so lightly that I'm doing little more than scraping the ink off and barely removing any metal at all. The other side of the prism groove is tricky because I'm trying to start at the edge of the metal, and the scraper blade often gets caught against the edge before it starts. After this pass, I think I've got to a point where it's worth testing the part to see how much it's been improved. The base feels very solid on the lathe bed, and tapping it at the back over the shims gives a very solid sound. It doesn't sound quite as good at the front on the prism. Moving it back and forth by hand feels much smoother, and there's no sound of metal edges scraping on metal. A dial indicator on the top surface shows essentially no movement when I tap the base from above. The The tailstock is practically scrap, so I'm not interested in investing much more time in it, but I've definitely made a huge difference to how well it fits the bed. It's a test piece for learning, and I've learned loads during the process. The main lessons have been to use a carbide scraper rather than steel, and to avoid having to scrape mild steel in favour of cast iron. I'm gradually getting a better sense of the technique, and it feels like a good time to go back to the tutorial videos now that I'll understand more of the content. As I think I've learned all I can from working on this part, I think it's time to move on. The next step in the project will be the headstock, but this has been quite enough for one video so far. I'm really looking forward to comments and feedback on what I'm working on here, as I'd love to learn how I can improve or what I could do differently that would work better. Keep in mind I'm learning from scratch, and I'm showing literally all of my learning process, including all the embarrassing techniques and mistakes. In the next video, I'll be focused on improving the shimming for the headstock. The goal will be to fit them so they start out in better shape, and to use a material that's better for scraping. Thanks for watching, take care, I love you all.